This is the real Tom Rose, and for solving this problem, we need to do a little even-odd jujitsu. So P and Q are prime numbers greater than 2. Anytime a question tells you such and such is prime numbers greater than 2, they're kind of speaking in code that both of those numbers are odd. Right? So even numbers are all divisible by 2, right? So there's no prime, all prime numbers are odd except for the number 2 itself. Right? So once you get above 2, primes are all odd. So when they tell you P and Q are both primes greater than 2, which of the following must be true? Well, for statement 1, remember P is odd and Q is odd. So you can write PQ plus 1. You can think of that as an odd times an odd plus 1. So an odd times an odd will always be odd. So this is the same as an odd plus 1. Now an odd plus 1 will always be an even. And evens are never prime. So statement 1, not only will it not always be true, but in fact it will never be true. So if you take 2 primes, multiply them together, and add 1, that will never be a prime number. Same thing is true for PQ minus 1. So PQ minus 1 is an odd times an odd minus 1, which is an odd minus 1, which is, again, is an even. So that'll never be prime. So 2 is not only not true, but never true. And 3 says P and Q do not have a common factor other than the number 1. In fact, that is the definition of prime. So a prime number is a number that has no factors other than itself and 1. So P and Q will each have themselves as a factor, and they'll also have the number 1 as a factor, but that's it. There will be no common factors because, in fact, there are no other factors. So 3 will always be true, so the third answer choice is correct.